Friends, in this video we are going to talk about insertion sort, which is a sorting algorithm in the data structure. So let us see an example how to sort an array of elements, and also we are going to see the code using Python, and we are going to execute the program. So for this, let us take an example and then we'll see how we are going to sort it using insertion sort, and then we'll be talking about the code. So let me take some example. Let me take an array of element, like I'm going to take 6 elements in an array, 22, 7 and 3. So this is my array. So here how many number of elements present in the array is 6, and the index will be starting from 0, 1, 2, 3, 4, 5. So the size of the array is 6, and usually we know the array index will be starting from 0 to 5. So how we are going to sort this array is using insertion sorters. First we are going to divide this array into two parts. Initially we are going to take only one element from this array. So whenever we consider only one element, so we know obviously it is a sorted one, right? So I'm going to take this only one value. So this is a sorted one. And the rest of this array I'm going to take as unsorted elements in this array. Okay, so what we are going to do is, first I am going to take one element I am considering as a sorted. After that I am going to take one by one element from this unsorted array, and I am going to place this element in the right place in the sorted side. So we are going to do two iterations. One, we have to go this side, take one by one element, and then the second iteration is move this side, the sorted array, and place that element in the right place. And then how long we will be moving here? Until we are reaching the index value 0, or else the element which we are going to take should be less than the value present here. So until the element we are going to take from here is less than, we are going to move to this left side of this array, that is sorted array. And we are going to take one more element here. That element or variable we are going to say as temp. We can name it as with any name. Let me name this variable as temp. So what I am going to do is, from this unsorted array, I am going to take the first element. Let me take this 24 here. So when I take this 24 here, which is the first element in the unsorted array, so what happened here? There I have a empty space, right? So here 22, 7, 3. So this is how it will be looking like after I take this element 24 to the temp. So here is a hole, right? So what I have to do here is, now I have to see where should I place this 24 in the sorted side. So here I am going to take two variables. So this initially, this first variable I am going to use is I, which is going to start from the index number 1. And then for moving or iterating to the sorted array, I am going to take it as j. So how can I say this j? J is one value behind I. So I can say j can be I minus 1. So which means if the I value is 1, 1 minus 1 is 0, right? So j is in the previous or beside this I value. So what I have to do is, how long I said I have to take one element from this unsorted array, and I have to check in the left side, which is the sorted array. So in this case, when there is a hole, what will I do? Here I have only one element in the sorted part. I'll compare 24 with this 15. So in this case 24 is greater than, which means the temp value is greater than 15. So since it is greater than, I don't want to do any shifting. So I'll be placing this 24 in the j plus 1. Okay, so this is j and this is j plus 1, right? So this is this place is said to be as now j plus 1. So in the j plus 1 place, I will be directly putting 24. Now what is this? This two elements is sorted and the remaining this part is unsorted. Again what we have to do? Again, so this is done. Now we have to take the next element from the unsorted array. So that is 13. So when I take 13 outside, now where will the whole? So this in this place we will be having the whole 22, 7, 3. So now if I have this as array, so now you can see I have the whole in this place. So what is the value I have to compare from the unsorted array? 13. I have to compare this 13 which each and every element in the sorted part. So first what will I do? I will compare 13 with 24 which is the sorted part. This side is j part, right? So I will be comparing 13 with 24. So when I compare 13, this temp value is less than 24. So if it is less than, I have to bring 24 to this empty space or the whole. So I'll be bringing 24 here. So now here I have the space. So if I make this array, so here I brought this 24 to this place. Now I have the empty place here. So already 15 is here, right? So now I have to check this 13 with this 15. So if you check compare 13 with 15, again 13, this 13 is less than the 15. So what I have to do? I have to bring this 15 to this place. Since this temp value is less than 15, I have to bring this 13, this 15 here. So now again we reach the 0th index place. Once we reach the 0th index place, then we can place the temp value in that place. So now what I am going to do is, I am going to take this 15. I brought this 15 in this place. I will put the temp value there. So the temp value present there is 13. So I will bring 13 to this place. So here we will be putting 13. So the remaining value is 22, 7, 3. So here is the array now after this step. So now we know this much part is now sorted. So this is the sorted part and now this is the unsorted part. So now 13 also placed in the right place. Again what we have to do? We have to take the next element in the unsorted array, which is 22. So when I take this 22 outside, so what happens there? There we'll have the empty space, which means we will be having the hole there. So I'll be removing this 22 outside. So when I take this 22 outside of this, here I have the hole. So now again I have to compare this value in the temp with the rest of the value in the sorted part of this. So first I am going to compare this 22 with 24. So this 22 is less than 24. So if it is less than means I have to bring this 24 here. So 24 will be coming here. Again I have to compare this 22, the value which is present in the temp, with the next value. Here if you compare 22 with 15, 22 the temp value is greater than this. So if it is greater than, then we don't want to move again. So this is the right place to put this 22. So I am going to put 22 in this place and the remaining value we are going to keep as it is. 30 and here we have 3, 7 and 3. So we got the next array after sorting or placing 22 in the right place. So now we know this much part is now sorted and now this is an unsorted part. So this we have to again repeat it. So what you have to do now next, again we have to take this value from the first value from the unsorted array, unsorted part, and keep it in the temp. So what I am going to do is I am going to take this 7 and I am going to keep it in the temp. So 22 is kept in the right place. I am going to take 7. So if I take the 7, this space become empty. So what will I do? Now I will be comparing this temp value with the sorted element in the left side. So if I take 7, compare with 24, 7 is less element. So I have to bring this 24 to this place, to the hole. Again I have to compare this 7 with 22. So again the temp value is less than this 22. So I have to bring this 22 to the hole. Again I have to compare this temp value with the next element, that is 15. Again temp value is less. So I will be bringing 15 to this place. Then again compare. We have to go until the temp 2 condition. We have to go till j value becomes 0. Also the temp value should be less than the value in the sorted place. So again if you compare 7 with 13, 7 is again less value. So again we have to move the value. So finally we reach the 0th index position. So keep the temp value in that place. So again we finish that iteration also. The remaining value is 3. So we keep as it is. Now we got the output of this iteration. So now if you see, now this much is the sorted part and this is a unsorted part. So again what we have to do here, again we have to take the element, the first element. Here this is only one element in the unsorted place. Take it and keep it in the temp variable, right? So here I am going to take this 3 and keep it in this place, in the temp. So now 3 is there. So what happens? Again we have to iterate. We have to compare this 3 with the elements in the sorted place. So first compare 3 with 24. So temp value is less. So we have to move this value one step ahead, which is in the hole. Then again I have to compare 3 with 22. So again 3 is lesser. So bring this 22 one step ahead. And then again compare 3 with 15. So again this time also temp value is less. So bring this one step ahead. And then again 3 with 13. So now 3 is again lesser value. So again move this value to the next value. And then again when compare 3 with 7, again the temp value is lesser. So keep it here. Have to move the 7 in this place. Okay. And then now finally we reach the 0th index. So finally we will be putting this 3, the temp value, directly in this place. So that is 3. So now we have sorted all the elements in the array and we got the sorted elements in the array. So this is how the insertion sort will be working. So now by seeing the steps, we are going to convert the steps to the Python code. Okay. So first what we are going to do is, so let us define a function so in Python we define all the function. Start with the keyword def and let me name this sort as, this function name as insertion sort. And what will be the input given to this insertion sort function? I'm going to pass this array, right? This unsorted array I'm going to pass to this function. So okay, I'm going to pass it. Then so how we started? While we started taking the element from the unsorted part of this array, which means we started from the first index. We are not starting from 0th index because we consider the first element, the 0th index, as a sorted one. So when there is only one element, obviously it is sorted, right? So we started from the 0th index, started from the index number 1 and we reached till the size -1. So the size is 6, so we went till 5. So for moving from this index number 1 to 5 in the unsorted part, we are going to write a for loop for iterating through the unsorted part. So for that I'm going to use a for loop. I'm going to take a variable called I. So we name this part as I, right? The first index. And then we are going to use I in range. So here we are going to say the starting value. So we are going to start the value from the index number 1 till the length of the array. So we know in Python, if you give some value as end value, it will take till the value, one value behind it, right? So if the length of the array is 6, so it will take 6 minus 1, that is 5. So it will be iterating from 1 to 5 in this case, if the array size is 6. So we use this for loop. Here we have just used the for loop just to iterate in the unsorted part of this array. So here we know in Python we have to end the for loop with a colon. And after that, what we did is, here we used a variable called temp. So what does temp carry? It's the first element in the unsorted part of the array. So for that, let me use a variable called temp. So initially, what will you put in the temp? In this answer, let me name this array name as ARR, right? So that is what we have passed to this array. The array name is ARR. So what we kept inside this temp? First we took the first value in the unsorted part. So what is the first part? ARR 1. So we are starting from 1, right? So I'll just say initially we are keeping the first value in the unsorted array. Here it is. The first value is we can say 1, or we can just say I. Initially just taking the first value, that is ARR of 1. And then what we did is, we said we are going to take one value from the unsorted part and we are going to place it in the sorted place. So we want to move right side, also we want to move to the left side. So to move to the left side, which is the sorted part of this array, I am going to take another variable called j. What is the value I am going to assign in j? So the j value will be 1 less than I. So I'll say I minus 1. So here the j value, if the I value is starting from here, so j value will be starting one value less than I. So that is I minus 1. So j will be moving this side, I will be moving this side. So we have initialized it. So this is what we have to do initially. So we are going to iterate from this index 1 till the end of the array. And then we are going to take a temporary variable where I am going to take the first element in the unsorted part of this array. And then I want to move or iterate through the sorted part of this array. So we have to move to the left side. So I am going to use another variable to move to the left side, that is sorted part. And so if j is starting from here, I is starting from here, j will be moving from, so one value less than this I. Now what we have to do is, we have to compare the temp value with the value present in the sorted, right? So if in the first case we have only one element in the sorted, second case we have two elements in the sorted, after that we have 3 elements, 4 elements. So here we have to iterate again to the left side of the which means the sorted part also. For that we are going to take another while loop. Okay, so this while loop help us to traverse through the sorted part of the array. So where is the sorted part? This side, in the left side. So how long we will be comparing this temp value with the sorted part? Until the j value is greater than or equal to 0. Also the temp value should be less than the value in the j, right? So this is what we will be doing. So here, so if you take a temp value, we will be comparing with this value, then the next this value. So how long we will be comparing? One is j value should be greater than or equal to 0. Also the temp value should be less than the value inside the sorted part. So this side we are traversing, that is j part, right? So I say, so first time this is j. So 24, which is present in the temp, will be compared with ARR of, which means array of the jth position. First time it is 0. Next time this part will become I, and this part is the j value. So here the index is 2 and this is 3, 4, 5, and here it is 0 and 1. So here always j value will be 1 less than this. So j value here is 1, and then we have to decrease every time. So here that we are doing. So every time we'll take the value from the temp and we have to traverse to the sorted part, that is left side of this. So we have to go until what? How long we have to traverse is by this, based on this condition. So that is j value should be greater than this index. This is greater than or equal to 0. Also the value from the temp should be less than the value inside this sorted part. Until that we'll be iterating. So you can see once the value here, if you see the value in the temp here is 24 and the value here 15 is in the sorted part. So the 24 is greater than 15. So what we did immediately, we keep it in the same place, that is in the j plus 1 value itself, right? So until we are satisfying this condition, what will we do? We will be moving this value to the next part. So for example, if this is the j part, this is I part, and so this is again j minus 1, this is j minus 2, it will be keep on going. So what I have to do, so if the value in the temp if is less than, so what I have to do, I have to bring this value to this place. So how will I name this place? This is j plus 1 location, right? So from, for example, here if this is j, and then so every time we will be decreasing this j. So now j is here. So like if I want to move this 24 to this empty place, I'll say j plus 1. Again when I decrease this j value, so j value will be going here. This is called as j plus 1 positions, right? I will say it is like ARR of j plus 1. In the j plus 1, what will you put? The j value equal to ARR of j. So if this condition satisfies, which means if the 13 is less than 24, this condition is satisfied, and the j value is also greater than or equal to 0, means then what will you do? In this place, now j value is here. So in the j plus 1 place, we have to shift this j value. So this ARR of I, okay, the index is 1, will be moved to I plus 1 position. So this will be done, and every time we will be decrementing j value, like j equal to j minus 1. So every time, next time what we have to do, again this 13 will be compared to 15. So I have to again push this j to this place, so j minus 1. So first, for example, initially here if the j I value is here, so which means if the index value is 0, 1, 2, 3, 4 and 5, so I value is in the 3, right, is in 3. So what is j value? I minus 1. So j value will be initially it is 2, and then we will be comparing the temp value with this value and we will be working. After that again we have to update the j value after next. So j value become 1, which means 2 minus 1. So already 2 minus 1. So again we know, again j equal to j minus 1. So 1 minus 1 is, again we will be moving j to, like it's how this is how the j value will be moving towards the left side. So if the condition fails, for example the temp value is greater than the value, what you have to do? We have to move directly. So in this case you can see if temp is having 24 and here is the hole, right here in this place I have the hole. Once I take this value to the temp, this place I have the hole. So when I compare this 24 with 15, 24 is greater than, so this condition greater value. So this condition doesn't satisfy. So what we will do? We will move this value, temp value, and then I'll put the temp value in the j plus 1 position. So this is j. So if this value, the temp value is greater than the value in the sorted place, then immediately what will you do? In the j plus 1 location, this is j. So this place is called j plus 1. In the j plus 1 location, you can see in the j plus 1 location, we will be placing the temp value, that is 24. So if the condition doesn't satisfy, we are going to say ARR of j plus 1 in this place, we will be bringing the temp value. So this is the code to do the insertion sort. So let's take a scenario and we will be working. So you will understand it clearly. So here let us take initially the I value is equal to 1. And then we are coming to this place for the first iteration. What is temp? Temp of ARR of I. I is now 1. So what is in ARR of 1? In the array of 1, the value is 24. So in the temp, I am going to put 24. And then what we say? J. So what is J value? I minus 1. What is I? I is 1. I is 1. So 1 minus 1 is 0. So now initially I is in this place, that is in the index number 1, and j is in the 0th index. So that's done. And then what we have to do, we are going to check the condition whether the j value is greater than 0 or greater than or equal to 0. So now if you see this case here, the j value is greater than like it is 0, so equal to 0, this condition satisfies. And then temp value. What is the temp value? Temp value here is initially the temp value is 24. So 24 is less than ARR of j. Where is j present? J is present here. The value is 15 for the first time. Okay. So temp value is containing 24 and the j value is ARR. Initially now the j value is 0. ARR of j is 0. So j in the 0th index we have 15. So this condition doesn't satisfy. So this condition fails. So if this condition fails in the while loop, both the conditions should satisfy. Here we have kept and. So if this condition doesn't satisfy, so it will come out of the while loop and in j plus 1. What is j plus 1? J is 0. So 0 plus 1 is 1. So in array of 1 position, which means here if you say j value is now in 0 plus 1 is 1. So in array of position 1, I have to keep the temp value. So what is the temp value now? 24. 24 should be placed in one place. So that is why you can see here we have kept the temp value, that is 24, in this index number 1. So we have now this part is a sorted part. So this one iteration is completed. First iteration is over. So what happened next iteration again? It go to the next next iteration of the for loop. Now I value will be incremented. So now the I value is 2. So now what we have to keep in the temp? I value, temp equal to ARR I. I value is now 2. So what is in the index number 2? In the index number 2 we have 13. So in the place of 24, in here in the temp we will be keeping 13. Now what is I? J value? I minus 1. So what is I value? That is 2. 2 minus 1 is 1. So now j value is in this place. This is index number 1. So here will be the j value and here will be the I value. Got it? And now again we have to check the j value. So now j value is 1. 1 is greater than or equal to 0, condition is true, and then again we have to check the temp value. What is in temp? Now we have in temp we have 13. 13 less than AR of j. What is AR of j? J is 1. So in the array index number 1 we have the value 24. So now the temp we have 13. And so this is the empty hole because this is brought to this temp now. So this is the whole place. So now we have to compare this temp value with the sorted part. So how will you compare? So now in this condition if you see 13, the temp value is less than 24. This both the conditions satisfy. If both conditions satisfy means what we have to do? In the j plus 1 position, j value is now in 1. So 1 plus 1 is 2. In this 2, index number 2, we have to place the value present in a array of j. J value is 1. So this is the index number 1. The value present in one index will be moved to j plus 1. So which means 2. So 24 will be moved to this empty place. So again we have a hole here. Then we have to again update the j value. So what will be the j value? J minus 1. So the j minus 1 is 0. J value becomes 0. So now j value is here. Now j value is here. Again what I have to do? I have to this while loop is not yet completed. So again I have to come and see j value is greater than or equal to 0. Yeah, 0. So it is equal to 0, condition is true. Again I will be coming to this part. What is again present in the temp? Temp contain 13. So 13, then less than. What is in AR of j? J value is 0. So in the 0th index I have 15. So this condition is also true. The temp value is less than 15, which means in AR of j. So again, if these two conditions satisfy, what we have to do in AR of j plus 1, we have to move AR of I. So in j plus 1, j is in 0th index. Now I have to move it to j plus 1. So 0 plus 1 is 1. So I have to move this 15. So this, you can see the 15 is moved to the next index, that is j plus 1. Now j is in 0th index. Now you can see j is in 0th index. So 0 plus 1 is 1. So this 15 is now moved to index number 1. And then you can see after moving, j value will be decremented as j equal to j minus 1. Already j contain what? 0. 0 minus 1 is minus 1. Okay. So now the condition fails because j value is less than 0. So the while loop condition is false. So I'll come out of the while loop. And then what it will do? In j plus 1 position. J plus 1 means it is j is containing now minus 1. Minus 1 plus 1 is 0. So in the 0th index, you have to place the value present in the temp. What is present in the temp? 13. So this 13, the value present in the temp, will be now kept in the AR of j plus 1. That is 0 minus 1 plus 1. J value is now minus 1. Minus 1 plus 1 is, that is 0. So in the 0th index, the temp value will be placed. So again this will be, so this iteration, the second iteration with I value is 2 is also over. Again this will be continued. Again what will be the value of I? I value will be, again now it will be 3. So now the I value will be 3. And what will be the value in the temp? So temp equal to AR of I. I value is 3. So what is the value in the third index? Now this is the first 0, 1, 2, 3, 4, 5. So now what is I? I is 3. In the third index now we have 20. Like after we move here, now what is the value present here is 22. So now this 22 will be brought to after 13. We have to move after 13. You can see we have to move 22 to the list. So we are going to move this 22 to the temp now. Again this iteration will be continuing in the same way. So finally we will be getting the sorted array like this. So I'll be showing the code, Python code for this. So this is the Python code as I said. So the first value will be always considered as a sorted part. The remaining will be considered as unsorted part. So it is starting from 1 to the length of the array. So always we know in the range it will be taking one value less than the stop value. Then initially we will be taking the first value from this unsorted part that is kept in the temp. And we have to move to the left side of the array. That is the sorted part. So we are saying j value, that is one value less than the I value, and then we know that we have to iterate, we have to compare the temp value with the value present in the sorted part, right? So for that we are iterating to the left side of this array. We have to move until the j value is greater than 0, and also the temp value should be less than the value present in the sorted part. And then if the condition satisfy, we will be moving the j value to the j plus 1 place, and then we will be updating the j value. Once this condition becomes false, we will be bringing the temp value to the place of AR of j plus 1. So we will be getting a sorted array. So here I am going to run this program. First I am going to get the size of an array list, and then you are going to put it in the list using append function. I am calling this insertion sort function where I have to pass this array inside as input to this, and after that we will be getting the sorted one. So let me run this program. It is asking the size of the array. Let us give the same value which we use for example. So we have 6 as a size of the array, and the elements we have there is 15, then 24, and then 13, 22, 7 and 3. So if we see here, now we got the sorted array. So this is how insertion sort will be working. I hope you have understood. Thank you.